Welcome to the Ethereum Simulator, a playground for Ethereum crypto contracts. So this is a little online program that you can also visit on your laptop, and you can use it to look at how contracts work in Ethereum. It simulates what Ethereum does in a simple way. It uses a JavaScript-like language to create contracts. Now in current Ethereum contracts you probably program a little bit more in the direction of Lisp, but this also gives you an idea of how it plays out and what you can do with it. Now up here you can see your wallets. So right now there's three wallets that have been created for simulation. And if we go to my wallet, then you can see that the value is 800. So there's 800 Ether in that wallet. And that can be used to do fun things like run contracts or pay other people. Below here we see the contracts: Namecoin, Cryptsy Feed and Hedge. First we're going to look at the contract Namecoin. And the Namecoin contract is interesting because we can test it and see how it actually works. So, for example, you can see that right now the Namecoin contract has been run once, and we can see that it has stored a key value, and the key is www.ethereum.org. The value is the IP address of Ethereum. So in Namecoin, the interesting thing is that when you use Namecoin, you have a decentralized DNS system. Now in Ethereum, they have replicated that functionality, at least the way of storing it. And as you can see, this contract effectively does store values. So let's just try and send some Ether to this contract and try and add something to the storage to see if it works. Just let me check what it's a while that I did this. Okay, so here we have, we want to send from the wallet to the contract Namecoin. And right now I'm just going to send 500 Ether, send a lot, and put 200 in fees. And then we can actually add data, and we could say, okay, we want to add a new bit of data into the Namecoin contract. So we say, okay, www.dogecoin.doge, whatever. In the Namecoin DNSs you can usually do .bit addresses, so let's make it .bit. Now let's see how we get to the next part. And let's say we just host it locally. Now if I click submit transactions, it sends the data to the Namecoin. Now if we look at the Namecoin contract, we can see there's now more Ether in the Namecoin contract than there was before. So the person who made the Namecoin contract, in theory, would have now earned some Ether. And, oh sorry, we have to look in the blockchain under here. And we can see at this block, there's new data here. We have dogecoin.bit located at 127.0.0.1. And the interesting part is that if we do another transaction, we can add data onto that. So let's do it again. Now my wallet doesn't have enough cash anymore, so we're going to steal some cash from cryptsy.com. And we're going to feed that to the Namecoin contract.
This runs on your website?
No, this is it runs on GitHub.
Okay.
Yeah, just a test phase, yeah.
Okay, www.douchebags.bit, and as we can see, we're now saying that the actually make it like this. We're now saying that the Google DNS is also locatable to douchebags.bit. And we can see an extra block has appeared here, and it's added to the Namecoin sequence. You can also see what code it ran, and it puts that data in there. Now, I'm not seeing both the data in there, so it's probably because I'm looking at just one block. I'm going to check if that actually works or if it's just more a proof of concept. I think in this case it's more a proof of concept.
Yeah. Works locally.
Yeah, it's not. It doesn't really work on the Ethereum test chain. So this is basically just to get a small feel for what contracts are. But if you want to make real contracts, I suggest you download Ethereum testnet and start working with that. And there's also another bunch of tools that you can actually run real Ethereum code on, and not just JavaScript-like code. So this is basically as a little proof of concept to show you what can be done. But it's way not the expanded way to create Ethereum contracts. Now, going in on that tonight would be a lot of information. I think most of you would not want to go that deep, but this shows you a little bit of how it works. So you send a transaction to a contract, and that contract just accepts that money or that value and starts going through the code. In the case of Namecoin, it checks, did we receive more than 200? And if it's not, if we didn't, then we'll just do nothing. Also, is there already data stored somewhere? If so, we do nothing. Otherwise, we store the data in our index. So let's say we try and create a transaction with only 100. We could probably not run through this contract. Let's try that. Let's send a new transaction. Let's say I throw 50 at it. I pay a fee of 50. Now here we see that this is the transaction that came through, and this is what it runs, but as far as I can see at the moment,
Did do it.
actually, yeah, it looks like it did it, but I'm thinking this is the block, but I'm not thinking it actually should have done it. So in this case it looks like it did it, but in practice it shouldn't have actually put that through. So it's either I'm doing something wrong in the simulator, or but I think if you really want to test the contracts and the way they work, you should go and get the testnet, and you can give better examples of how it works. I also have a little film of this, and I'll see if I can find that. Put it on the screen. Some really good code you can find on GitHub under Ethercasts. So you go to github.com/ethercasts, and there you can see, for example, the Make It Rain application for Ethereum. And if
Shilling coin.
Yeah.
Shilling.
Yeah. And if you look at YouTube, you can also see how he did it, and also his code, how it works. And you can see here he created an HTML page that runs a bit of script right there that communicates back to an Ethereum contract. This is just JavaScript, but the Ethereum contract itself is in Lisp, as you can see here. See? And it looks a bit different than what I just showed you in the Ethereum Simulator. So if you really want to go dive into the code and start testing stuff, I'd suggest you get to the real testnet and start testing stuff there. There's also another tool to do that.
But am I right that Ethereum is kind of like a meta programming language? So if you write it in Ethereum and Ethereum compiles it to any kind of programming language.
You write it in programming languages that look a lot like Lisp or like C,
Yeah.
and then it can be compiled to Ethereum bytecode. Yeah, by a compiler.
Yeah, okay, but so the running program itself is in Ethereum.
Yeah, the running program itself looks a lot like assembler,
Yeah.
and it's much more compact than, for example, if you have the command when or the command suicide, which I suggest you don't perform on yourself.
Yeah.
You see that there's a lot of letters for one command. In
Yeah.
bytecode, that's all a lot smaller, and that's why you compile it to bytecode.
Yeah, but I mean, you can write the program in Lisp and compile it to Ethereum bytecode.
Yeah.
Okay. So you don't need to write it in Ethereum. You don't.
Ik ben bijna kwijt.
Yeah. Sorry, no.
Yeah, once again?
No.
So yeah, I think the best way to go about this is that we want to just organize a small hackathon to really, and then that we all have computers and just start
Yeah.
testing code. Because on the screen here, well, I can tell you a lot, but you'll probably quickly forget it, and the best way to learn is by doing it yourself. So besides that, I have not yet compiled my own Ethereum test environment, and I'm going to do that soon. But I have many things to do, so this is one of those things in the pipeline. It doesn't look too difficult to me, but it would be nice to do it together with a lot of people to just, to get a feel for how this works.
Where are the small amounts of ethers going to that are connected to a transaction?
That's a good question. They actually remain in the contract, and the person who owns that contract can empty that wallet. Some of the ether is used by the contract itself, and that goes back into the ether network. And by proof of stake mining, the miners can retrieve those transaction fees, so that there's also an incentive to keep the network running.
Good.
Yeah.
What was the difference between value and fee on that other side?
Well, basically, they're the same thing, but a fee to run a contract, there's a more or less a minimum fee to be able to run a contract, because a contract will have a certain size, and you can count the amount of steps and the amount of ether that will cost. And so at the beginning of your contract, you'll most often put a few lines that actually specify that if that amount is not fulfilled, and that's the fee of the contract will not run. On top of that small fee is also the amount that the contract itself costs to operate. So, and that depends on what kind of contract you've designed.
Yeah. So for example, I could write a program in Ethereum, and I could sell it to people to have the right to run it. And I could say every running instance costs whatever, and gets paid to me, for example.
For example, but you won't be selling the actual contract. You will have made it, but because you're the owner of the contract, that contract, if it becomes popular, will pay itself.
Yeah,
And it will also,
because I maintain the wallet
Yeah.
of the contract.
For example,
Yeah.
or it will just pay itself. There can even be contracts that don't make any big money, but that just make sure that they can keep running.
Yeah.
But yes, you can also create contracts that pay you, but then it will be up to the users of that contract to define if you're worth that amount of money or not.
Yeah.
But if I have a very good marketing club behind me, like a group of marketing people, and I copy paste an open source contract that does well, in fact, and I build a large community for that via the normal channels. That would be a smart way to earn a lot of money.
It would, and I think that's a big problem, and that will probably occur.
Okay.
So just like with the coins then, and the diversity in coins, you now see a lot of pyramid-like scams of coins that
Yeah,
were just
exactly.
created for
To
a fun effect and try to
Yeah.
reel in people's cash. Certainly that will happen in Ethereum as well, in contract systems. We'll just have to find out and see how we can counter that.
Collateral damage.
Well, I think that's realistically a bad way of creating contracts, but we will, as of yet, have no way to punish that. So that's the downside of decentralized systems. It creates a lot of diversion in which people can try and grab market share for themselves. And I think it would be good for us to think about what kinds of things we can come up with that will counter these things. Perhaps a contract that automatically recognizes these other contracts and starts warning people, for example, not to send money to it. Something like that.
You mean, in fact, someone could copy your code and say
Exactly.
it's their code?
No, just use it, it's open source.
Oh, yeah.
Yeah, no contract in the Ethereum blockchain is closed source. All the bytecode will be open source. Yeah.
So I just copied down and I used my marketing network to...
Yeah, because it's bytecode, it's not binary code.
No. Well, yes and no.
It's an assembler.
It's called bytecode because it runs on top of another binary that still interprets that.
Yeah.
It's assembler code.
It looks like assembler, yeah.
So you could,
Had je hem nog niet nee. Ik zit
with a little, you could easily, between quotes,
Tegenwoordig met telefoon is het niks meer voor.
reverse engineer it.
Yeah, very.
Because it's
That
binary.
I do not know. I think that would be more difficult because bytecode is always much more simple in its basic structure.
Yeah.
But if you're good at decompiling, it's more or less possible. Just like with normal code, it's just a lot of work.
But what is the problem with it? It's a problem that you it's not easy to make a business model with it that you can earn money from it.
No, sure, you can make business models. That's no problem.
But
But it's not that you're selling code. It's that you're creating a contract,
yeah.
and so it will be the contract that is your business model, not the idea of selling your code.
Yeah, but someone else can copy the code and make it cheaper, and then your business model is open. Yeah.
That's true, and I think that's the reason why
Yeah.
many Ethereum contracts will eventually become bare bones. So eventually the cheapest one wins, and that's the person who's not making a profit.
Yeah.
So in that sense, there's an incentive for people that want to do something good
Yeah.
to be able to win.
Yeah.
Let's hope it pans out that way.
Yeah.
But what do you mean that you think that it will become bare bones? You mean that you can buy a better program, but then it doesn't run in Ethereum or something? Or?
No.
It will be free for everyone then.
Let's say
Yeah.
somebody creates an asset, and you can buy that asset, and the asset is chocolate, for example.
Yeah.
And people can buy so much chocolate for so much Ethereum, or Ether, but they have to pay a little bit on top so that the guy who wrote the contract becomes rich. Another person could think, hey, well that's interesting, but I just want that contract to be brought out for free. So he makes the same contract, and then he says you only have to pay me what I need as money to send you the package and just make a living, instead of a lot on top of that. And in that case, that contract would probably win in the long run because it's cheaper to run that contract. And ordering large amounts of chocolate from that person would be cheaper.
Yeah, it's like you said, it's because it's decentralized, it's part of the system, to say it like that.
Yeah.
Yeah, so the first developers will earn some money because they did a good job, and then they will, it will turn out to be like almost for free. Like in, what is it, in website development. You can do it yourself, you can also ask someone.
Yeah.
Okay.
It sounds like normal competition.
Yeah.
Yeah, but the difference is that if you have a good business idea and somebody wants to buy it on the current system is you need the person that thought it out. You need that one too. You need to buy him in the idea. And I feel...
Well, the difference with traditional, for example, if you set up a lottery in the traditional way, you create a website and you host the web and you host this code that accepts money and then sends out money for the lottery case. You could also say you create an Ethereum contract and then you create hooks that people can hook a website to, and then just host it decentralized, for example in Tor or something. people send their ether to that and they participate in the lottery, but after that they don't need you anymore. If they just send money to that contract, the contract is the lottery by itself. You could create a lottery that doesn't earn you any money, but it's just a really cheap and fun lottery to participate in. And even if you just go away and do something else, that lottery will stay in the blockchain and people can just have fun and work with it. And that's just like writing open source code. You just do it once. You write a contract once and it's an open source contract and it can be used by anybody. So that's a very different way of working. A very, very different way to do business than in the past. And then maybe we can start focusing on things like, okay, how can we create ethical businesses, or businesses that do more than just automatic transfers of money? Because then we all just don't have a use for creating automatic transfers of money anymore, because it doesn't earn us any money anyways. That's a possibility. I'm not saying that would happen. I don't know.
That's the really, really, really long run. Because at the moment when someone is making a beautiful code, he's been working on it for like 4 months. It would be nice that he can pay his bills and get some fries and a beer.
Yeah, I know.
It's a little bit the problem of open source then at this moment.
That's one of the downsides.
Yeah.
Downsides of open source. That in practice you are working for free and you don't get anything.
Yeah.
Because in the community, people often say that it's all good and you do it for fun, but you have to live also.
Yeah.
And so I mean, I know a lot of brilliant open source developers who are living from the streets.
Yeah.
So that is also one of the reasons why, although I organize a lot of open source meetings, I understand the closed source side of the story. And,
I think that's always going to be an issue because open source is already, we already have open source for a long time. So yeah, and people have had trouble with that, and I think that will remain the case. There's always the case where you need to pay the bills and still want to do something good for the world. That's just problematic.
I had a conversation with an old COBOL developer, and he said to me, what's all this buzz about open source? Because he said to me, in the 70s everything was open. It was open by nature. When you bought a printer, you got the code with it, because otherwise it would never work.
Mm-hmm. Yeah.
So, but at that moment it was natural. So they didn't call it open source. It was just the way it was. And there's a famous story about Bill Gates, who sent an open letter to the developer community in 1982 or something, in which he said that people. It's very nice that you all that you all spread your code for free, but we are going to do it otherwise, and the rest is history, I guess. But I mean, he did it otherwise because he wanted to find a way to sell software, because until then people didn't really sell software. You bought a machine and you got a programmer with it. So.
Yeah.
So it remains a problem.
Yeah, and it will certainly become a problem, I think, in the crypto scene, because right now, if somebody wants to, he can understand how the blockchain works, he can understand how simple transactions work. But also, if somebody wants to, he can still understand how a computer works at bit and byte level, even if they're not completely open sourced. Sometimes you have quite closed hardware. There's very often you can still get hardware that's open enough, and if you just spend enough time, you'll find it out. But most people, that's the problem, don't have that time. The complexity has become so large that you're not going to waste months on end trying to understand that complex smartphone that you have in your hands, just to know how to route it from byte 0 to the end. So most people are not content with that anymore, and that's something that businesses nowadays monetize on. That's why closed source still has its place, because people are just too lazy to do it themselves. I think the same is going to happen in cryptocurrencies, that we're going to see a lot of complexity arise, in which more and more complex financial instruments are developed, and then people are just going to be too lazy to find out how it works, how to send the blocks themselves.